Once you remove common factors, you're then going to look for special product or special factor forms. And once again, these are the reverse process of what we talked about in the last section. And so one of the special factor forms that you need to identify is the difference of squares. So if you recognize something as being the difference of two squares, it's always going to factor into the sum and difference of the terms that are being squared. Okay, so this was the special product form. A sum and difference of terms being multiplied is equal to the difference of squares. And so now we're just working in the reverse direction. Okay, so if you had something simply as this, let's go 4x squared minus 49. Okay, what you should be able to do is recognize that you're dealing with perfect squares in both of these terms. What term are you squaring to get 4x squared? 2x, and to get a 49 you're squaring 7. So if you take those two terms, 2x and 7, and you multiply the sum of them times the difference of them, that becomes your factored form. Okay, now this process you may do mentally. You don't have to write it out. Again, I'll always write it out just to make sure that it's demonstrated. And so what would you get for the following? Okay, how would you factor this expression? Once again, you should recognize you have the difference of squares. What's the base being squared to get 36? And negative the 49x squared is 7x. So when you factor this out, you get 6 plus 7x, the sum of the terms, times 6 minus 7x, the difference of those terms. Okay, now, anytime you write your factors, here's the way I'd prefer them to be written. I always want you to write it in standard form. And so if that's the case, what you would need to do on this is you'd need to reorder these first pair of terms, and then also reorder the second pair. So this would be standard form. Okay, but in addition to that, what I'd like you to do is make sure that all the leading coefficients of your factors, the individual factors themselves, are positive. And so this one is fine. The 7x plus 6 stays just as it is. But in order to get the leading coefficient of this next factor to be positive, what do we need to remove from both terms? Remove a negative. So we bring the negative out front, and it changes the negative 7x into a 7x. And then the positive 6 becomes a negative 6. So here's the form that I would prefer this to be written in. One, it allows for consistency, and when I'm entering things online, it's always nice to be consistent. And second, once you guys start using these factors in different forms, so finding zeros or solutions or whatever, it's always easier to work when your leading coefficient is positive and when it's written in standard form than it is to try to work in the other direction. So just for consistency, remove your negatives. And in fact, that becomes a step 1 up here. Remove common factors. So if you were approaching this problem right here, the way that I would like you to approach this problem is think of it in the following way. It's not written in standard form, so I would write it in standard form first. And then remove any common factors so that right away you get your leading coefficient to be a positive. So if you factor out a negative, leaving a 49x squared minus 36, what you can then do is fit it into this special factor form, the sum and difference of the terms, 7x and 6, sum, difference. And so you get your factors, and it's easier if you remove your common factors in the first step rather than trying to remember and do it later at the end of your rewrite. Okay, so this is one of the special factor forms you need to be familiar with. The other factor form that you need to be familiar with is what's called a perfect square trinomial. And this is just the expanded form of a binomial square. And so once again, this was one of our special product forms. You now need to be able to identify it in the reverse direction as a special factoring form. And this form is called a perfect square trinomial. And the way that you look at a perfect square trinomial is you look to see what value is being squared at the beginning and end of your expression, a and b. You're then going to double that and check it. Does it equal to whatever this middle term's coefficient is? Right, so a times b, when you double it, do you get this middle term? Yes. If it is, then you have this binomial square form. Okay, so if you looked at an expression in the following form, okay, first thing, always look to remove any common factors. So are there any common factors you can remove from all three of these terms? No? So then you move to figure out, are your first and last terms perfect squares? What base can you square to get 4x squared? And what base can you square to get 49? Okay, if you double these, if you take the product of 2x and 7 and then double it, so 14x doubled, is that equal to this middle term, 28x? Yes. If it is, then you know you have this binomial square with the terms 2x and 7. And then the last thing you need to do is look at the sign of whatever your middle term is. Whatever that sign is the sign that you're going to place between your terms. Okay, so this is perfect square trinomial, special factor form. It factors into a binomial square. All right, I want you to see if you can factor this expression in, please. All right, how many of you started by removing any common factors? Okay, remember, that's always what you want as your first step. Okay, so what common factor can you remove from these two terms? Take out a 9, you're left with an x squared minus 4. And now, does this fit the pattern of the difference of squares? Yeah, it's the base x squared minus the base 2 squared. So if you take the two terms, x and 2, take their sum and difference, you get your factor. And now, let's say you didn't do that. Let's say the first thing that you noticed was, are you dealing with two perfect squares here? Yeah, so you could think of this as 3x squared and 6 squared. So if you thought of it in that form, your two terms would be 3x and 6, the sum of them, the difference of them. If you left it in this form, you'd only get half credit. Okay, because are these completely factored? No. What you would then need to do, you could still get the right answer from this if you removed common factors from each individual one. So 3 times an x plus 2 times a 3 times an x minus 2. 3 times 3 gives you 9x plus 2, and then the x minus 2. So you could still end up with the correct form of the answer. It's easier to remove common factors first. It just takes less time, gives you smaller numbers to work with, and will always put it in the simplified form that you need to have. And so I do encourage you to make sure that you remove common factors first. Right, the last thing that I wanted to go over was the only new pattern for you, and that is the sum or difference of cubes. Okay, if you have two perfect cubes that are either being added or subtracted from each other, there's also a special product form that you can memorize and apply. And here's the way I always present this. Okay, if you're dealing with either the sum or difference of cubes, you're going to have two factors, a binomial and a trinomial. The binomial factor is just going to be the sum of the terms that you're given. So in this case, A is being cubed and B is being cubed, so you're going to take those two terms and add them. Your trinomial factor is going to be the first base squared, so we're going to square A. The last term of our trinomial is going to be the second base squared, so it's going to end with a B squared. And then if you take the product of your bases and you subtract it or change the sign, that's your middle term for that trinomial. So a times b, change the sign, and you get your middle term. Okay, so that's how, again, I would present the sum or difference of cubes. So if you're looking at an expression like the following, the way that you would approach this is, again, remove any common factors first. Once you remove any common factors, you're then going to look to see, are these both perfect cubes? Okay, what base can you cube to get 27x cubed? 3x. And what base can you cube to get, carry the sign with it, negative 64? Negative 4. So if you think of that, carry the sign with it, it allows you to only have to memorize one form and not both. And then your factors are going to be a binomial and a trinomial. The binomial is just going to be the sum of these terms. So 3x plus a negative 4. And then the trinomial, you're going to square your first term. So 3x squared, we square the 3, square the x. Our last term is going to be the next term squared, or the next base squared. So negative 4 squared is plus 16. And then our middle term is just going to be the opposite of their product. So 3x times a negative 4 is negative 12x. Change the sign, becomes a positive 12x. And that's going to give you your set of factors for that expression.